Alright, we're going to learn about finding multiples and prime factorization in order to find the LCM. Okay, so let's talk about what a prime number is first of all. So prime numbers are numbers that can only be divided by 1 in itself, or you can only get them by multiplying 1 times the number. For example, 3 is a prime number because the only way to divide 3 is either by 1 or by 3 evenly. It doesn't divide by anything else. It has no other factors other than 1 and 3 to get 3. 6 is a non-example because it can be divided by 1, 2, 3, and 6. So all of those numbers make 6 a composite number, not a prime. So let's do some practice. Okay, is 5 a prime number? How do you know? And I would say 5 is a prime number because the only way to get 5 is to divide 5 by 5 or 5 by 1. There's no other way to multiply to get 5 except for 1 and 5. What about 8? Is 8 a prime number? Okay, no, it is not a prime number because first of all, it's an even number, which means it can be divided by 2 automatically. So that rules out the rule for it can only be divided by 1 in itself. Now there is a little exception to this rule, and that's with the number 2. 2 is an even number, but 2 only can be divided by 1 in itself, so it actually is a prime number. It's kind of like its own special number. Okay, so keep that in mind. We're going to be talking about prime numbers with factorization in just a little bit. Okay, so what is a multiple? A multiple is basically it's just like skip counting. So if I'm finding the multiples of 7, I'm going to start with 7 and count by 7. 7, 14, 21, 28, 35, 42. And when you're looking at this definition, that is the product of the given number. So 7 here, this is 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, 7 times 6, and it goes on and on and on. Multiples never end. You just don't need to keep listing them forever. So I want you on your whiteboard to list out what are the multiples of 4. Just take about 10 seconds to do this. Okay, so hopefully you started with 4, because you have to. 4, 8, 12, 16, 20, 24. So that goes on and on. Okay, now do 9. Take about 10 seconds to do that. Okay, here are the multiples of 9. 9, 18, 27, 36, 45, 54. And again, it goes on and on and on, but I'm just stopping there. So keep this in mind because we're going to use multiples as another strategy to find the LCM. So I keep saying LCM. Does anybody know what LCM is? It is the least common multiple. So least obviously means lowest. Common means it's a common characteristic. They share the same trait. And multiple, we already know what that is based on what we just did. Just keep counting numbers. So the least common multiple is the smallest multiple that is common to 2 or more numbers. So for example, how you find the LCM is you find the multiples of 2 numbers. In this case, it's 3 and 4. Then we're going to look for the ones that are in common. And then we just find the smallest one, and that's the LCM. So go ahead and pause the video while you do this, and just list out the multiples of 3 and the multiples of 4. I would list out like the first 10 or so. Okay, when you unpause the video, you should get all the way up. I did all the way until 30. I did the first 10 multiples of 3, and I only did the first 8 multiples of 4. But I really just want to keep in mind what is in common. So by in common, I'm looking, well, I have a 3 and a 4, 6, 8, 9, 12, 12. Hey, that one's in common. So 12 is in common with 12, Let's keep looking if there's any more. I don't see. Oh, here's another one, 24 and 24. So that's a number that's in common, but what we really care about is the least common multiple. And that would be the first one I came to, which is 12. So the least common multiple between 3 and 4 is the number 12. This, you're probably thinking, why do I need to know LCM? This is silly. It's actually for fractions. We're getting ready to add and subtract fractions, and we'll talk about the proper way to add and subtract fractions. If they have a denominator, the down number, that's different, you can't add them. So you have to use LCM to change the fraction with a number that's it's in common with both of them. So if I have a number that is a denominator of 3 and a denominator of 4, I'm trying to add them, I can't do that until I get a common number. So that's why I would use 12. All right, let's have you practice some. So I want you to list out the multiples of 9, list out the multiples of 12, find the least common multiple, then do the same thing with 4 and 10. And unpause the video when you are ready for the answer to the first one. Okay, here are the answers. For 9, I started listing out the multiples, got all the way to 63 before I stopped, and then I started listing out the multiples of 12, and I stopped once I got to 36 because I knew that 9 is a multiple of 36 and 12 is a multiple of 36, so here's my LCM, my least common multiple. And one thing Mr. Matson likes to do is he'll list out the multiple until you get to the other number, so like 9, 18 passes 12, so then he'll alternate. So he'll do 12, and then he'll do the next 9, then he'll do the next 12, the next 9, so that way you know when to stop. I kept going with my 9s, and I didn't even need to. I could have stopped once I'd gotten to 36, because that was the common multiple. So try that when you do 4 and 10. Just start alternating. Pause the video while you do this. Okay, so what I mean is, if I'm finding my multiples of 4, I'm going to do 4, 8, 12. Okay, now I've passed 10, so I'm going to go back and forth and skip count my 10s. 10, 20. Let's keep going to this one. 16, 20. Oh, there we go. 20 and 20. I can stop there because I've gotten to a number that's in common with both 4 and 10. So this is one method to find the LCM. I'm going to show you another one, and then you get to pick which one works best for you. Sorry about my voice. Okay, so prime factorization is really fun. It's making the factor trees. And factors are just numbers that multiply to get that number. It's not going to do you any good to use 1, so don't use 1. If you get to, like, 3 would be 1 times 3, just stop there because that means that's a prime number, and that's what we're looking for. So I have 9 and 6, and I'm being asked to find the LCM between 9 and 6. So I can use prime factorization to help me find the LCM. I know that, of course, 1 times 9 equals 9, but like I said, that doesn't help me at all. I'm just going to have to do this step again. So I need to find the other prime numbers that are factors of 9. And I know that 3 times 3 equals 9, and 3 and 3 are both prime numbers. And then I'm going to do the same for 6. So 2 and 3, and 2 and 3 are both prime numbers, where 2 is kind of that special exception to the rule. So what I'm going to do is list out the prime factors of 9, like this, and the prime factors of 6, like this. And I have this little box ready for me because 3 and 3 are in common already. I am only going to copy them once, and I'll show you what I mean by that. So to find the LCM, what I do is I take the 3 that's by itself, the 2 that's by itself, and then this 3 I can combine because it's shared between the 9 and the 6, so I only need to write it once. So then I just do these prime factors multiplied together, and I get 18. So I don't even need to list the multiples. I just know that between 9 and 6, 18 is the least common multiple. Let me show you another example, or have you practice one. So what I want you to do is do the prime factorization of, let's start with just 16, so on your whiteboards or paper, list out the prime factors or the factors of 16. How do you multiply to get 16? And there's more than one way you can do this. Okay, so I know that 4 and 4 equals 16. You also could use 2 and 8 and you would still get the same answer, I promise. So, but I use 4 and 4 because that's the first thing that comes to my mind when I think of 16. And 4 is an even number, so that's a composite, which means it's not a prime number. That's really what I care about. It's not prime. So I need to factor it again. So here's my little tree, my factor tree. I know that 2 times 2 equals 4, 2 times 2 equals 4. So I have my prime factors, 2, 2, 2, and 2. If I multiplied all those together, it would equal 16. Now let's do 8. Okay, what multiplied together equals 8? 2 and 4. Okay, 2 is already a prime number, so I just stop there. But 4 is not, we just did that, so I have to multiply or factor that out. So I get 2 and 2. So the prime factors of 8 are 2, 2, and 2. If I multiplied 2 times 2, I got 4, times 2 equals 8. So I'm just multiplying those things together. So let's use these numbers to figure out what our least common multiple is. I don't know why this is moving. Okay, so 16, I'm listing out my prime factors, which are 2, 2, 2, and 2. All of those numbers multiplied together, sorry. Now for 8, I have 2, 2, and 2. Okay, so I am going to, I'm going to drag these little boxes around the common ones. So there's a 2 in both the 16 and the 8 column. Here's another one, and here's another one. Okay, so what I do is I'm going to take, here's this 2, here's that 2, here's that 2, because I only need to write it once, and then this 2. And I can take those 4 2's and multiply them together, and I get 16. So the least common multiple between 8 and 8 and 16 is 16. There we go. Okay, if I rewrote all of these 2's, 2, 2, 2, 2, 2, 2, I would get a gigantic number, and that would not be the least common multiple. Okay, so here's your last practice. You can use either method, either listing out the multiples of the number and finding the least one, or you can use prime factorization to find the multiples, but you need to find the LCM between 2 and 7 and the LCM between 8 and 12. Pause the video while you do this and unpause it when you're ready for the solution. Okay, for 2, I'm going to start listing out 2, 4, 6, 8. Okay, and I'm past 7, so I'm going to start alternating 7, 14, 8, oops, 10, 12, excuse me, 14. Okay, and the reason why I kept doing this is because I was trying to get to 14 or past 14, and I got 14. So I see right now that the LCM is 14. They both have it in common, and it's the lowest one, the very first one I came to. Okay, I'll do this. LCM equals 14. Now for this one, 8, same thing. 8, 16, okay, 12, 24. So now I'm trying to get to 24 over here. 16, 24. There we go, done. So my LCM equals 24. Okay, you have problem set and homework that has you practicing the skill of finding the LCM, starting with finding multiples of numbers and then factoring out numbers. So make sure you read the directions carefully to make sure that you're not doing more work than you need to.